Alright guys, welcome to 7.3 video underway, and let's go ahead and talk about what we are talking about. So our essential understandings for this chapter are the following. You can show that two triangles are similar when you know the relationship between only two or three pairs of corresponding parts, and then also sometimes you can use similar triangles to find the lengths that cannot be measured easily under a ruler or measuring device. So two different kind of things we're going to tackle today. Let's get into it. And this is our big key right here. We have three keys. Now, if you guys recall, we had congruent triangle rules like angle, angle, side, side, angle, side, those things. Now we have a quicker way to show that triangles or triangles are similar. Before we had to list out all three angles are congruent and all three sides are proportionate in a triangle, so we had to prove 6 things. Now we can minimize it down to fewer things. So let's go ahead. You have to write each one of these down, so please write them down. But we have what's called side-side similarity. So if I can show all three sides are proportionate, we automatically know the triangles are similar. Again, we're doing what's called similarity theorems, not congruency theorems. So side, side, side is our first one. And I'm going to just take note of it right over here because we have 3. Let's move on to the next one. Make sure you write down each one of these, please. And so let's just go to the next slide. One moment. Okay, and here's our next one. It is side, angle, side. So if I can prove two sides are proportionate and the included, very important that we write included, angle is congruent, we can do side, angle, side. So again, we have 3 of these. Make sure you write down the theorem and draw the picture. So you want to do both of these. So we should have 3 theorems written down at the end of this. And our very last one, so I'm going fast, so you're going to have to pause it. Our last one is angle-angle similarity. So this one's new to us completely because we've never had just an A and A. But these are what's called our similarity theorems. This one's actually a postulate. And this is how we can show two triangles are similar without having to prove 3 angles congruent and 3 sides are proportionate. So a fast way to do it works only with our triangles. Let's get into a couple examples real quick to see how this will play out. Okay, so first one is angle-angle postulate we're going to use. Are the two triangles similar? How do I know? First of all, we need the two triangles to appear. Here they are. For AA, we just need to show that 2 angles are congruent. First off, 45 and 45. So I'm pretty sure angle R is going to be congruent to angle V. So that helps us. There's an, not an S, sorry about that. There's an angle that we have congruent. If we can show that we have 2 angles, we're in the clear. So we got 1 angle. And then right here is our second angle. These are vertical angles. We know vertical angles are congruent. So angle S is congruent to angle S. And this is again an angle. So we have 2 angles. So are the two triangles similar? Yes. Then we need to write our similarity statement. And that would be triangle RSW is not congruent. Keep trying to do congruent. We're talking about similarity here. Is similar to triangle. R matches up with V, S is going to match up with S, and B is going to match up with W. Alright, let's take a look at our next problem. Are the triangles similar? If so, write a similarity statement for the triangles. Well, I have no information about angles in this picture, so my only guess is that it might be side, side, side. In order to do this, I need to set up and make sure that these sides are proportionate to each other. Now, I don't know which side which matches up with which, so what I'm going to do is I'm going to take the largest sizes down to the smallest sizes. So we're going to take, we have a left triangle and a right triangle, and I'm going to do right over left, and I'm going to do 15 is going to compare to its largest side, which is 10. And then let's do 12 compared to its second largest side, 8. And then let's do black, 9 compared to 6. So I kept it consistent. I took the right side triangle compared to the left side, and I went from biggest to biggest, medium to medium, and small to small. So all we now have to do is reduce these and see what we come up with. So I believe 5 goes into both of those, so that's 3 over 2. So if these are all the same ratio, then they're similar or proportionate sides. If we have 3 proportionate sides, then these triangles are similar. 12 and 8, I believe 4 goes into both of those, so it gives us 3 over 2. And I know 3 will go into both of these, and it gives us 3 over 2. So they're all proportional, so I know I have side, side, side. And we can say these triangles are similar, so I'm going to do STU is similar to triangle. And now this is the tricky part. We want to make sure we put this in the correct order. So I'm looking at S is between the blue and the black here, so I'm going to say X is probably going to match up with that. T is between the black and the orange, so I'm going to say V matches up with that. And U is between the blue and the orange, so I'm going to say W would be the one that matches up with that. Well, that was a big box. So, all right, there we go. Let's look at our next problem. Okay, so this is our third problem now. We're going to actually do a proof to see if these triangles are similar. So we're going to go ahead and do that. Remember, we always start with a statement, and then we go after our reason. Okay, so whoop, whoop. Here we go. So first, let's go ahead and take an approach to our strategy. Looking at our picture, MP is parallel to AC, so that's in there. So what am I looking at? Well, I see that these angles are going to be congruent because they're vertical, and then I see alternate interior angles here. So there it is. AA is what I'm going to be going after. Let's go and try it out. Statement 1, let's always do our given. MP is parallel to AC, and the reason? This one's easy, given. Okay, statement 2. All right, I'm going to jump right into getting C and M. So angle C is congruent to angle M. And the reason why is because they are alternate interior angles. If you look at those two parallel lines, I guess like this, they're on the inside and they're alternating. So we're going to do alternate interior angles theorem, AIA. So we just proved one of our sides, so we can do a big S and say, oh, dang it, I always do that. Not S, this is an A. So we proved one angle already. We got to prove one more angle. So 3, I can show that B is congruent to B, or CBA is congruent to PBM. So we get CBA is congruent to angle PBM. And the reason why is because of vertical angles. And that gives us our second A. Once we've proven both A's, we can go ahead and write in our prove statement. And let's go back to our original violet. And we can just say triangle ABC is similar to triangle PBM. And why? We would say angle, angle, postulate. Okay, or we could say angle, angle, similarity would work as well. All right. And one final question. I know this one's kind of a long note, so here we go. Last question here. And this question is going to pertain a lot to our project. And we have a picture here of a guy before he's rock climbing. Darius wants to know how high he will climb. He places a mirror on the ground and walks backwards until he can see the top of the cliff in the mirror. What is the height of the cliff? So what we're actually doing is we're using similar triangles to go ahead and find a piece. So we are most interested in X right here, and we want to see if we can set up a proportion. And in fact we can. Since these are similar triangles, the height of him is going to correspond to the height of the cliff. Okay, so hopefully you're taking notes on how this is corresponding to our project. So I'm going to do the cliff triangle compared to the height of our little guy there, what's named Darius. And then we want to say, okay, so we went x to 5.5, then we're going to do 34 to 6. So the horizontal or flat piece, we are going to use 34 to 6 feet. And here we can go ahead and pass out our calculator, and we can do a little bit of math. So we're going to get 6x. It's a little hard to see, so I'm going to actually flip this over and rewrite that. So x over, 5.5 equals, and what was it? 34 over 6. Okay, and we're going to cross multiply here. So we're going to get 6x equals, and then we have 34, so I'm just using my calculator here, 34 multiplied by 5.5, and so we get 187, and then we're going to divide by 6, which is going to give us a decimal. So the height of our rock quarry is going to be about 31.16 repeating, and we're going to go ahead and take a look back at our original one, and we were talking about feet. So our final answer will be in feet. So that's how we can use what we call indirect measurement to figure this out. And if we flip back over to our screen, we can actually learn about indirect measurement right here. And so I'll have you guys write that down as our last thing today. You can use indirect measurement to find lengths that are difficult to measure directly. End quote. Okay? Alright guys, thanks so much. I will see you later.